In these examples here, we're going to compare two statements, decide if they are saying the same thing, if they are equivalent statements. And the way we're going to do that is just create truth tables for the two arguments. So I'm going to start by creating a truth table here. And just a little summary of the truth tables. This, again, this very handy little table kind of summarizes what you need to know when you want to create a truth table. So in this first question, we have here a PQ and an R and a PQ and an R in both the statements. And so I'm going to create a PQR. And so recall that for 3 arguments, we have 2 to the 3 rows. We're going to have 8 rows in this table. So we go down and we have 4 truths is how we're going to build this out for P. And then we'll do 4 falses. And then we'll do 2 truths and 2 falses for Q. And then we'll do 1 true and 1 false for R. And that will give us every possible combination. So I'll resume the video after I type that in. So just note what I said here. I did 4 truths, 4 falses. Then I did 2 truths, 2 falses, 2 truths, 2 falses. And then here I just do true, false the whole way down. And that will give me every possible combination. Now, in this first statement right here, we kind of use order of operations here. We look at parentheses first. Let's do not R. So not R is going to be the opposite of true, false all the way down. It'll be false, true all the way down. And our next column is P or not R. So remember, the disjunction is false only when both P and Q are false. So when both P and not R are false. So let's look down through here. Here's some falses. There's false, false, and there's false, false. So that row there and that row there are false, and the rest of them are all true. And now we're going to do not Q. Not Q, so Q is true, true, false, false, true, true, false, false. We're going to swap all of that and do false, false, true, true. And so recall our last one now is the conditional. It is false only when the first thing is true and the second thing is false. So these are the areas where we want to look here where not Q is true. So in these 4 rows here, the preceding statement is true, but then the second is true. We're looking again for when P is true and Q is false. So true, and right there, when Q is true, not Q is true, and P or not R is false. So that one's going to be false. And so that resulting truth table is everything is true except for the next to last is false and then true again. So now what we're going to do is create a truth table for R and not P, then Q. And we're going to compare the ending result to this result. So I'm going to reuse all of my PQs and Rs that I set up the first time here. I'm going to grab those, I'm going to copy them, and I'm going to bring them over here and paste them over here. And so now I'll set up this truth table. The first thing we need to do here is R and not P. So let's set up not P. So not P is going to be false for 4 and then true for 4. So now in this part we're going to do a conjunction. So let's scroll back over here and look at conjunction. Conjunction is true only when both P and Q are true. So we're looking for 2 truths here between R and not P. So we look for 2 truths, and that's true. And 2 truths, and that's true. The rest of them are all going to be falses. So we'll fill in the rest of the table. And then our final step here is R and not P, then Q. So if R and not P, then Q. So recall for a conditional, it's false only when the first thing is true and the second thing is false. So let's go down and look for some truths. True, true. Here we have true, true. So those are true, and all the rest of them are true. So everything in this table is going to be true the whole way down. Because in the 2 cases right here where the antecedent, the first part, was true, the second part was true as well, which made that still stay true. It would have only been a false if it was true and then false. So our question said, are these statements equivalent? And we would say here the statements are not equivalent because they have a differing truth value right there. Alright, so let's scroll down and look at the next one. We're going to do the same thing, but now it's in terms of words, and we got to convert these words to symbol. So we have, it is not true that birds do not flock together, and there must not be an early worm. So let's let P be birds do not flock together. suppose we could also let them be flocked together and then use a negation. But I'll just keep it as it is in the original statement. And then Q is going to be, there must not be an early worm. And again, you could write that in a negated sense as well. And so if we want to write those two things together, we have an and, so we have P and Q. And it is not true. So we're going to take all of that P and Q and do not in front of that. So just to re-emphasize here, it is not true that the birds do not flock together and there must not be an early worm. So we want to try to find which of these is not equivalent. So the birds flock together or there must be an early worm. So notice the birds flock together, that's not P right there. Or there must be an early worm, that's not Q. Alright, so that's how we could write that one with symbols. If the birds do not flock together, so if P, and here I'm coming down here, if the birds do not flock together, then there must be an early worm. So P, then not Q. Is what that statement is. All right, come on down here with this one. If there must not be an early worm, if Q, then the birds flock together. So that would be not P. And finally, the birds flock together, so not P, and there must be an early worm. That would be the opposite of my Q. So we're going to try to decide here. We have these four statements, not P or not Q. P, then not Q. Q, then not P. And not P and not Q. Which of those is not equivalent to not P and Q? All right, so I've set up some truth tables here to check all of these out. So let's do the original statement first. So we have P and Q. Remember, that's only true when everything is all true, otherwise it's false. And then there's a not in front of that, so we're going to negate all of that. So when we do the not, we get false, true, true, true. All right. Now let's do answer choice number 1 here, not P or not Q. So not P or not Q. So let's make a row of not P and one of not Q. So we'll alternate and do false, false, true, true. And not Q is going to be false, true, false, true. And then we're going to do an or statement. So remember, that's only false when both things are false. So false or false is false. Otherwise, it's all true. All right, so you can already see that these two are the same. Now let's do, so we did that one. Now let's do if P, then not Q. P, then not Q. So let's get some not Q's in here. That would be false, true, false, true. And then we're going to get P, true, and then false. Remember, it's false when we do our conditional statement. True is true, that's true. And of course, when it starts with a false, that's true as well. So that one is equivalent. Now we're going to do the third one. If there must not be an early worm, then the birds flock together. That was Q, then not P. So we have a not P. Let's make a not P column here. So that's false, false, true, true. And we're going to do if Q, then not P. So Q, then not P. True, false ends up being a false. And false, false is true. True, true is true. And false, true is true. So that one's equivalent. So this last one must be the one. But let's confirm not P and not Q. So let's make a row of not P. That would be false, false, true, true. And Q, not Q would be false, true, false, true. And then we're going to do a conjunction of those two. So the only time it is true is when both things are true. So there's true, and the rest of these are all going to be falses. So it's 3 falses and a true. So going forward, you could create the truth tables at any time, but also notice one thing. When we did a not on a conjunction, that means we got 3 truths and a false. And recall that anytime we have a conditional, we always get 3 truths and a false. And recall that for an or, we also get 3 truths and a false. The only time we don't get 3 truths and a false would be with this conjunction down here. So when we negate things, we're basically switching things around, but this conjunction down here is going to have 3 falses and a true because that's what conjunctions do. So we're going to learn here just on the next video things about the converse, the inverse, and the contrapositive, and there's a relationship between conditional statements and those variations in those statements that we can use to then summarize and not have to do 5 truth tables here. So anyway, look for that in the next video, and it'll be the next one in this sequence of videos.